So welcome back to our lecture series on call divergence and gradient. Now this is another example, a typical example on that call. So it says if P is equals to x squared yz I plus xyz squared j plus y cubed zk. So we are asked to determine the call P at 0.211. Okay. So the question is saying this is what we are asked to determine the call P as 0.211. So basically what this question is trying to say is that you first of all look for the call of P. Now the answer you get as a call of P, you are going to call it again. Exactly. So that's basically what the question is saying. So once you find the value of call P, whatever you get as your answer, you are going to find the call of that answer again. Exactly. So with that explanation, you might just want to pause the video and attempt it on your side and see if you are going to arrive at the same answer. So, and let me know what your answer is in the comment section below. And I click on your bio. Somebody is distracting me here. All right, so now let's get started with this solution. So remember for call, so let's first start with the first call. So if you have to look for call P now, so, and don't forget for call, one thing you need to remember if you are dealing with call is just have it in mind that matrix kind of arrangement, exactly, so that you don't mix call with divergence or gradient. So that will be I, J, and then K. Okay. And then, so that's for the first rule. For the second rule, you are going to be having the partial differential x and then partial differential of y and then partial differential over partial differential of z. Are we good? So for the third rule, that's where you're going to be having the coordinates of the function itself. So for this now, we are going to be having this, which is x squared yz. So you don't need to include the I. And then for this, we are going to be having x, y, z square. And y for this, we are going to be having y cube z. Okay, so now let's go ahead and simplify this. So in doing this now, we are just going to look at it from how you listen. Like I said earlier, if you are dealing with call, just look at it as you are trying to look for the determinant of a 3x3 matrix here. So that means our call P. So we can also write it like this, as our call P will be equals to, so let's start with I, and then open brackets. So when we are dealing with I, everything on this particular row, this column, we are just going to ignore it. So we are going to multiply this and subtract this. All right. So that will be partial differential of y multiplied by y cubed z minus partial differential of z of xyz square, then minus j. So we are done with the one with I. So let me. So now for that of j, so once we are dealing with j also, we ignore everything on this particular column. So we are multiplying this and then we'll subtract the product of this. So for j, we are having partial differential of this over x, that is this one, multiplied by this, that is y cubed z minus, so this now d over dz, that's delta, sorry, this is z, not x, that's z. So again, when you are dealing with call, you need to pay attention to some of these values at the lower end, because if you mix it up, if you write y where you are supposed to write z, it will affect your answer. I think I had that issue in one of the example I was doing. So you need to be very careful with that. Then multiply it, what we are having here, which is x squared yz. Okay, so now let's go to k. Now for k, now we are going to be having plus k. So let me just take this one off. So now that we are dealing with k, we are going to ignore. So you are going to ignore everything here. So what we are multiplying now is this, the product of this minus the product of this. So let me do that. So we are going to be having partial differential of d over dx multiplied by xyz square minus partial differential over partial differential of y, which is this and this, multiplied by x square yz, and then you can close it. All right. So now let's tidy this up. So if you have to differentiate this, so let me just put my I. So if you have to differentiate this with respect to y now, so since we already have y here, that's going to be z minus, so now let's differentiate this with z, since we have z squared, so that's going to be 2xyz. Are we good? Then minus j, so we are done with this. Now let's come over to, so with this now, if you have to differentiate this with respect to x, this will just give us 0 because we are not having x here. Then let's move over to the next one. If you have to differentiate this with respect to z, so we have z here. So if you differentiate that z, that's differentiation of z will give us 1. Okay, and since the differentiation of z is giving us 1, this x square y will be a constant, so we are just going to write that x square y. Okay, so now let's move over to k. So plus k. So let's differentiate this now. We are differentiating this with respect to x. So this is x here. If you differentiate x, that's 1. So we'll be left with yz square as the constant. So we are going to write yz square. Then minus, so let's move over here. So if we differentiate that with respect to y, so this is y. Differentiation of y is 1. So we'll be left with x square z. So x square z. Okay, so this is what we are going to get if you find the call of p. So this is for call p. This is for call p. And the question is asking us to look for the call p. Exactly, we are going to look at call p. So now we are going to calculate, now that we've gotten the value of call p, now we are going to calculating for call p. So again, we are going to have something like this. So the notation for that call p is okay. So now we are going to repeat the process again. So that's call p. So that's equals to, so we're going to draw our matrix. So this will be I, j, and then k. So let me just give it enough space. And then this is going to be partial differential. So that of x, for this is for that of y, and this is for that of z. All right. So now let's put in for the I coordinates, so which is this. So this is z minus 2xyz. All right, so before we proceed, there's a little correction I need to make here. So from the question itself, the question that I'm making reference to, this is y square, not y cube. So you might just need to correct that. So this is y square. So that means here is going to be y square, and then this is also y square. So if this is y square and we are to differentiate this, so this won't be ordinary z. So this will be 2yz. Okay, so that's the only correction there. Okay, now so let's continue. So this will be, so what we are having here on the I coordinates, we are going to write it out here. So 2yz minus 2xyz. And then for the on this column, so it's going to be for that of j, which is x square y. And then for k, we are going to be having yz square minus x square z. All right, so now let's go ahead and look for just calculate it. Like I said, you just calculate it the way you calculate for determinants. All right, so the call p, so that will be I. So this will multiply this, so we are going to be having partial differential of z and partial differential of y multiplied by yz square minus x square z minus partial differential over partial differential of z of x square y. So let me just make it square brackets. So that is for I. Then minus j. So since we are considering j, we know everything here. So what we are multiplying is this will multiply this minus the product of this. Okay. So that will be minus j. So that will be d over dx. And then yz square minus x square z minus partial differential is of z into bracket 2yz minus 2xyz. So let's close this, then plus k. So now we are dealing with k. So since we are dealing with k, we ignore everything on this particular column. And then, so the multiplication for this now will be, this will multiply this minus the product of this and this. So for k now, so that will be d over dx multiplied by x square y minus d over dy multiplied by 2yz minus 2xyz. Let me just chip this in. Minus 2xyz. So just let me just put it there like that. All right. So let's tidy this up. All right. So now let's start differentiating. So if you have to differentiate this now, so let me just put my eye on standby. So if you differentiate this with respect to y, so this will be z squared. So if you differentiate this, we are here now. If you differentiate this, this will be z squared. So for this now, it will be 0 because we don't have y here. So that is it for I. Okay. So minus, so let's come over to this side. So for this now, if you differentiate this, so in differentiating this, this is z. This is z. Because if you consider y, is this multiplied by this and d over the z and y. So just take note of that. That's a mistake here. Okay. So if you have to differentiate this now, there is no z here, so this becomes 0. Are we good? So with that, that is for z. So let's go to minus j. So if you have minus j, so let's see what minus j is. So if you to differentiate this now with respect to x, so there is no x in this one, so this is 0. So here we are having x, and if you differentiate it, that will give us minus 2xz. Are we good? Then minus, so let's come and differentiate this with respect to z. So So differentiating this with respect to z, there is a z here, so this will just be 2y. And then we already have z. If you differentiate it, this is 1, we'll be left with minus 2xy. So minus 2xy. So you also need to note that this negative sign that we are having here, this is it here, and it's for everything inside of this bracket. So if this make negative to multiply this is going to become positive. Are we good? So you need to take note of that at that point. All right, so now let's do for k. So for k now, that will be plus k. So let's open our bracket. So if you have to differentiate this with respect to x, we already have x here, that will be 2xy. So that will be 2xy. So now let's come ahead, head over here. So let me just continue on this line. So if you differentiate 2yz with respect to y, so that will just give us 2z. So that will be minus 2z. And then here we're having minus 2xyz. So if you differentiate this, it's going to give us minus 2xz. Exactly. So minus 2xz multiplied by this minus we are having outside, it becomes plus 2xz. And that is for k. All right. So another thing you need to take note of is if there is this, once there is this negative, and then remember that everything inside this bracket belongs to this negative. So depending on what the value is giving you when you differentiate, you might need to multiply the negative and negative to give you positive. So just like what happened here and also happened here, to make this positive and this also made this positive. All right, so that you don't miss the sign, because if you miss the sign, you miss this answer. All right, so now let's clean this up. So now that we've looked for the called P and called P, now let's go. The question now says that we should look for called P at 0.211. So just like I said in one of the previous examples, when you are given a point, you only put in the value of those points at the end of the answer. Exactly. So now we can, at this point now, we can say that at point. So what are the points again? At 0.211, which is this here. So at 0.211, so that means our x is equals to 2, our y is equals to 1, and our z is equals to 1. So again, so this is where you're going to put it at the end of, because this is what we're asked to look for, called P. So don't do the mistake of putting your value of x, y, z here, because here you've just gotten, let's say, one part of what you're asked to calculate called P, and what you're asked to calculate is actually called P. All right, so let's put in the values. So that means our call P will be equals to, so z square, so let's say our value for z is 1, so that was 1 square will just also be 1. So let's just write it as 1i, exactly. So then for this now, we're having minus 2xz, so that's minus 2 times our x is 2 and our z is 1. So that would be, so let me just put minus j into bracket minus 4, and then here we are having 2, so 2 times y, that's 1, so that will be minus 2 plus 2 times x and y times 2 times 1. So that will give us minus 2 plus 4. So let's head over to k. So we are having plus k. So right here we are having 2xy. So that is 2 times our x is 2 and our y is 1. That will be 4. That will be 4 minus 4 for 2z. So 2z is 2 times 1. So that's 2 times 1. That will be 2. Then plus 2xz. So that's 2 times x. That's 2, and then times 1. That will be plus 4. Alright, so now let's just tidy this up. So call P is equals to, so this one I, you can just give it as I. Then here we are having minus j. So if you simplify what is in the bracket, minus 4 and plus 4, so we left with minus 2 plus k into brackets. This is 4 plus 4 minus 2, that's 6. So with this now, our final answer can be written as, will be written as call p will be equals to I. So minus j multiplied by minus 2 plus 2j plus 6k. And this we are having here is the answer to this example. So this is what you are going to get. Let me know if you got it. Let me know in the comment section if you're able to get the same answer with what we are having here. So that is it on call when you're having multiple functions in one, multiple operations. All right, so I hope you find value in this. If you do, please give it a thumbs up. If you have any question or doubt, just let me know in the comment section below, and I'll see you all in the next one, because the video continues in the next, this lecture series continues in the next video.